Welcome to Cornerstone Home Inspector Education Center. Tonight we have Jeremiah Weed from Barlow Water Pump Systems, and he's going to be talking about water and wells and a bunch of other things. And I'm going to hand it over to him. If we have any questions tonight, just type it into your chat pod. And if you're not asking a question, if you'd like to ask a question live, just unmute yourself. But if you're not asking a question, try to keep your microphone muted. So I'll hand it over to Jeremiah.
Hi, thanks for having me. So I'm here tonight. I'm going to talk to you about some of the things to look for when it comes to, wells and well systems. So if you have any questions, feel free to just ask, and I'll be glad to answer as we go. This is my first time doing it on a Zoom or meeting like this, so bear with me if I'm a little slower than normal. Some of you guys may have seen something similar to this. I did it, I think, back 4 or 5 years ago, something similar. I stole some of the slides from there. But basically, I just wanted to kind of cover some of the things to look for when you come across a well. Everything is different, and I understand that you guys probably face the same problems that we faced through COVID. A lot of people didn't inspect their wells or have any well inspections at all. Moved in and found out they didn't have water or very poor water quality, which seems to be the big one. We had a lot of water quality issues since COVID, since all those real estate transactions took place. So just I'll run through some things. Like I said, if you have any questions, let me know, and I'll stop along the way and answer them any way I can. So the first thing we have is this is like the perfect situation for us. One of the problems that we have is it's very hard for us to find information about wells. If the homeowner doesn't know anything about the well, we probably won't know very much about it. So it's great when we have this information here. Some of the health departments do have online databases where we could get some information, but what we found is it's not reliable. Some of it's in lot numbers and not addresses, and we found out that as the health departments have updated their databases, they put wrong information in wrong files. So this is great information when we have a customer that does this. It's not very often, trust me. I didn't do it at my own house, and I really should for anybody else. But this basically tells us how deep the well is, where the well pump is set, when the pump was put in, and things like that. So that's good information for us. Like I said, we don't see it very often. I wish we did. All the pump manufacturers, they give us stickers with all this information so we could leave it behind. In our industry, though, we don't like to leave information behind because the next guy will get it. I don't agree with it, but that's how it is. In a lot of states, Connecticut's not one of them. It's actually code that you have to have the well information in a metal plate that's riveted to the wellhead, which again, I think is a great idea, but Connecticut does not have that law. This is just another picture of a system that kind of makes you wonder. You see the bucket there, so there's some leaking at some point. So that's why I just showed you this one. We had, again, people buying houses, and especially this past year with all this water, we had a lot of people calling with foundation leaks and things like that. In the case of this picture, it's simply the well overflows through the wire conduit, and that's what happened there. So that's a great problem to have an overflowing well. It's not common, but this year we've seen quite a few of them, more than we'd like to admit. Most of them turned into some water damage, unfortunately, when the basement's flooded from it. Same thing here. This one actually was a vent from the well right into the basement. So just things to look for again. Things that you don't think about normally when it's dry outside, but this flooded a basement, unfortunately, for some folks. This one, unfortunately, was just a poor seal around the foundation. The reason I'm bringing this up is these are some of the recent things that we've come across. And of course, we hear that how come the inspectors didn't find it? Shouldn't the old homeowner have told us about these problems? Honestly and truly, in some cases, they may have never leaked before. We've been to houses this year that have had wells that overflowed, and people have lived there for 30 years and never saw it happen before. So, they assume that there was a problem. This is what's called a pump tech system. this is something that we would ask you to look out for, especially for you guys that are doing well inspections. This is a big red flag if you see a pump tech, or now they have pump savers. They have a little fuse system. Anything that says pump protection device generally is not there to protect the pump for any reason other than a low producing well. So they're expensive devices, and let's be honest, homeowners are cheap. They don't put them in unless they absolutely have to. So a pump tech device, generally a pump tech, a pump saver, a little fuse, they're not generally part of a normal installation. And when you see something like that, you should be very concerned about that.
Hey, Jeremiah, what would the call out be? What would I tell a customer?
So whenever you see it, like I said, a pump tech device, usually it's because of a low producing well. So that's what I'm concerned about. Other than that, I mean, very rarely do we see them for any other purposes other than at the end of an electrical line where there's some low power issues. It will protect against low voltage as well. But very rarely would you put it in for that. Generally, any of these pump saving devices are meant for dry well conditions. So the pump doesn't melt and burn out once there's no water around it. And that's generally why they're put in. And I think I'll have some more pictures. So this is a different version of the pump tech. It's same manufacturer, just a little bit of a less expensive system. Just again, so you have an idea. A different model. This one has an infrared, so you could connect to it with your phone to give you history and data. So again, same thing. This is just moving on to water quality. You could see the orange there. That should be a big red flag. And something I wanted to talk to you guys about was water testing. For those of you that do it and don't do it, water testing is going to become a bigger part of probably your businesses, I would think. If it's not, it should be. We have coming up the pike in the next couple of years, there's going to be a lot of lead testing being done in schools and daycares and private industry, where the EPA is going to mandate a lot of child care centers and things test the water for their licensing. We're currently, a lot of them do not have to do it, but there's a new lead and copper rule coming down that's going to require daycares and preschools and things like that, child care centers, to do this testing yearly. So that could be a good business for you guys. But some of the things you see here is, I mean, just look at this sink. These people probably lived here for 30 years with the water like that. Of course, the new homeowners, you know, how they missed it through the walkthrough is beyond me. But when they move in, they see that. And of course, it's someone else's problem. But the other big red flag that I see at this faucet is there's a drinking water system there. That's that small little faucet to the right of the main faucet. And that's a reverse osmosis faucet. I could tell that's what that is because it actually has a TDS monitor in the bottom of the faucet. And generally, again, homeowners do not install reverse osmosis systems unless there's a problem. The problem could be a couple things. It could be lead. It could be sodium and chlorides because we have a lot of those now in the water. So when we see something like that, water testing should always be a recommendation to say, hey, why do you have this? Let's test the water. And again, if we have time at the end, I'd like to talk to you about water testing as far as when, where, and why to test for certain things that we see coming up. This is the same house here. Oh no, this is a different house. I'm sorry. Same thing though. There's a drinking water system. These houses were actually in the same neighborhood. They're both foreclosures. And same thing, just a lot of iron in the water, and there was something in the water. This was actually how the water was coming out of the faucets or out of the hose here. So this could just be from sitting though. So don't let this, if you see water coming out of a well looking like this out of an abandoned house, I mean, don't really condemn it. There's things we could do to clear it up. One of them is just basically flushing the water. Turn the water on and let it run, and it will clear up.
Jeremiah, what's your recommended time for a potability test to let it run?
So every well is different. There's no time. What I say is we could cover this more if we get into the water testing. But what we see, the worst thing is when people let the water run for hours and then they take a test, it almost always comes back bad. So my personal reference is within the first half hour before the water turns. Because what happens as we're pumping these wells down, Um, as you bring the water level down, you let water that's in the ground into the well that may be dirty. Again, think of a swimming pool. This water at the top of the well is touching the air, so it's turning colors. As the water level drops down lower and lower in the well and gets closer to the pump, you start introducing this dirty water into the pump system and into the house. So the water that the house is generally using, you would see within the first half hour. Now, I caution you when I say that, because lead testing becomes a big issue, and I'm sure you'll have questions about that down if we get to water testing. But I usually say in the first half hour. How I do it and how I try to teach our guys is we go in, we get the water running, we do some amperage checks, we do static water level tests, and then we do the water testing. So usually it's a good 15, 20 minutes has gone by, and then we'll take some samples and fill out the paperwork and continue our checks. But this is some pretty nasty water here. This is just showing you a UV light hanging there. So again, that's a little concerning. Now, this is what's called a shallow well pump. So I would assume the well isn't very deep here. I didn't take this picture, but I see a shallow well, which means that the well is usually less than 30 feet deep. There is a ultraviolet light. So it would make me think that it's either a hand dug well or it's a very shallow well. Generally, when you see that, I mean, we would recommend a new water system. If it's a hand dug well, for a couple of reasons. One is a lot of the mortgage companies will no longer give mortgages on a hand dug well or a shallow well. They want a drilled well. This one, actually, there's no red flags on this one. I think I just threw this one in here to show what it should look like. Tank's in fairly good shape. There's a pressure relief valve at the bottom here. There's a check valve. Everything here looks really good. So I don't have any problem.
What do you want the pressure to be on that pressurization tank?
So the pressure gauge, the pressure gauge could fool you. So we get a lot of customers that call us here and say, hey, I have no water. And our first question is, what does the pressure gauge say? It says 60. Well, and they have no water. So chances are the pressure gauge just gets stuck. So I wouldn't give too much credibility to these gauges. They're very inexpensive. It's a small, little 1/8-inch hole that actually connects to the spring. So they get plugged up with iron and hardness and calcium. So usually we'll see they don't work very well. If it does work on a system like this, we generally would like to see the pressure. So pressure switch works in two ways. So a pressure switch is the gray box right there on the bottom, and that turns on based off of pressure. So generally it's a 20-pound pressure differential. So they make them in 20-40, 30-50, and 40-60. So generally houses nowadays have 40 or 60-pound pressure switches. So you should see between 40 and 60 pounds. That's where we generally would see it. Now I had a lady call today. She said, last night my pressure gauge was at 58 and today it's at 45. You got to get someone here right away. I have no water. And I said, well, why do you have no water? She goes, because whenever I look at it, it's always at 60 and now it's lower. I said, but is there water coming out of your faucet? And she's like, of course there is. So I had to explain to her how, there's a 20-pound pressure differential. And, if it gets below 40, that's when you should be concerned about it. But 40-60 is generally where we would like to see it, unless you get into constant pressure, which I don't know if I have any slides on that. If I do, I'll explain that a little bit more. But constant pressure is usually set at a certain pressure. We'll say 70 pounds. And usually it will vary 2 to 3 pounds either way. So it may drop 3 pounds, it may go over 3 pounds, but it usually stays right around that 70 PSI.
Okay. Jeremiah, if we see a larger pressure spread, is there any reason for that? Are they trying to make the system run longer or get to a higher pressure?
No, generally it's just a bad pressure switch. It's just a spring, and depending on how old they get.
We're going to blame everything on the pressure switch now?
Yeah, that's what it's going to be. Same thing if you'll see a lot of times that the pressure switch just gets plugged with iron or calcium, and it doesn't turn on fast enough either. So the pressure will drop down pretty far before it turns on, and vice versa. A lot of cases it will build extra pressure than what it should and blow the relief valve. So these pressure switches are something that should be changed or at least cleaned out regularly. It doesn't have to be every year, but at least every couple of years.
When you change the pump, do you change the pressure switch usually?
Yes and no. Every customer depends. So it's not part of it. We recommend it, but that $40 is a lot of money to some people. So some people won't change it. And then we're back 3 weeks later because the pressure switch went bad, which is unfortunate. So we give our customers options, if they want to change it or not. When it seems like when you give them options, though, they never do it. This one here I have because there's no pressure relief valve. So you would always, any system you'd want to see a pressure relief valve. Generally, you would see them at the bottom of the well tank. So you would see, so here's the pressure relief valve here. You should have it somewhere in the system. So nothing there. This one is just, you see there's really no problems with this other than the tank is, my recommendation would be to replace this tank. It's pretty rusty, unfortunately. Oops, went too far. Same, this one here, no real problems here at all. Just showing you some good stuff instead of all the bad. This one here, again, no pressure relief valve. I would say this, I don't know who would install this tank like this, but they must have liked the solder. That's all I could say.
What's the general life expectancy? I don't know if you said it before.
No, I haven't. So life expectancy of anything to do with a well currently is about 12 to 15 years. That's currently. Now, 15 years ago, we would have told you it was 15 to 20 years. All the manufacturers now have changed their and I'm sure you guys I'm sure they've told you, they make these things to last like appliances now. So the same thing as a stove or refrigerator, washing machine and dryer. They want them to be replaced, so they make them to last, 12. We see them go bad in 8, but average, I would say a good average is 12 years. So we make notes on not all of them, but some of our inspections that, that the tank is in bad shape, the well pump's in bad shape. In this picture, there's a water softener off to the left. It's not in great shape. It's past its useful life expectancy. You should expect to replace it sooner than later. Just to put it in their air. We see it's unfortunate. There are some manufacturers out there that are making their pumps to only last 5 or 6 years. They're also less expensive pumps, so they're not the greatest. But we have unfortunately pump companies in Connecticut installing them because it's cheaper. They don't, they get the replacement business as well. So they're happy to do it. This one here, I wanted to show you this picture for a couple of reasons. We've run into, over the past couple of years, people that, they move in, they had a great water test. And I'm sure this will raise some questions or concerns. And then they move in the house and they have staining or they have, other problems. And what we found with COVID, or not just with COVID, but what we found with, we don't know if it's realtors, we don't know who it is, but they get the good water test. And then we run into the problem of where did that water softener backwash to? So the answer is we just bypass it or take it out. And as we move out, and then the people have bad water. When they clearly had a good water test before, and then we start doing some inspections and see that there's a water softener in the basement or whatever the case is. So I would say just document if there's water softeners there. One of the other things we've run across is Culligan. It does rental units. They're the only people in Connecticut that do. And they, of course, when the folks move out, they take the water softener with them. And, the potential home buyer or the new homeowner thought the water system was in place and the water was good. So we've seen some crazy things like that. Mostly though, we see people take their water or they just bypass or cut the water softeners out to get past the dry well issue and the septic issue. I don't know what's right or wrong. I think I think you should at least disclose to the new homeowner that you're going to do that if that's your option.
Should there be a jumper cable to bypass for the ground for the sediment pump for the sediment filter?
In this case, no, because the copper is not broken through here.
Okay.
So if it didn't have these T's here, this bypass, yes, it should have. And I
Okay.
think there's gonna be some that show you that, and maybe another picture. You could see they did some grounding here as well for something else. But yeah, so you're correct. There should be, and you don't see
Jeremiah,
it.
neutralizers go in the septic, right?
They could go to septic. They could go to septic. Carbon tanks could go to septic. Arsenic and uranium systems could go to septic as of this year, as of January 1st. Water softeners still cannot. Iron filters still cannot. So water softeners never will. Ever, I don't think.
We see it all the time.
Oh, yeah. Well, there's still companies that install them the septic tanks today. I was just at a brand new house on Monday, and I was there for something totally different, and they just had a water softener installed, again, by a big national company, and it goes right into the septic. I said, did they tell you about it? Nope. They just put it in. So, I educated him, and I don't know what he's going to do, but I wasn't even there for that. I'm a nosy guy. Once I get in, I start following pipes and stuff, and I came across it. So, yeah, water softeners will never go to septic tanks in Connecticut. Rightfully so. They shouldn't, especially if it's for removing hardness. We've seen, over the years, you guys are part of this. You've seen where they said it, was deteriorating the tanks and distribution boxes. We could all agree or disagree on if it did or not. What we are seeing, though, is the sand in the leaching fields are plugging up from the hard water. So our association, the Connecticut Water Well Association, we don't want it to go to the septic for that reason. We don't want to be ruining any part of any septic system. And iron filters were going to be on the table this past year to add to what could go into a septic system. But again, if we're going to put all this iron into the septic tank, it's going to plug up the leaching sand. So we asked them to not put it in there. So where we're at now, we're pretty happy with what can go to a septic system.
We also see them in the storm drain too, connected to the downspout on time to time. I mean, if you really think about it, dry wells going under the ground too, but that is still not legal, correct?
So I can't answer that 100% for you because, and I'll be honest with you, I can't answer that question because all that it says is it can't go to the septic tank. It doesn't say you have to put it to a dry well. It doesn't say you have to put it anywhere else. That low flow wastewater treatment permit was something we had asked for to give us somewhere to put it, but it doesn't say that we can't put it on top of the ground. It doesn't say that we can't go to the downspouts. However, if you go to the new homes that have these, leaching systems, if they have a 100-year overflow, you can't put them on into there. So some places you can, others you can't. So if it's, I was just at a house where it was dumping into a pond. I was like, well, I think that's the worst idea in the world. Like you're putting this water into the pond. But there's nothing in writing yet that says it. I mean, I wouldn't do it personally, but there's people out there that will do it. And they're going to, one of the people on our Connecticut Water Well Association is, hey, it's not in writing. I'm doing it. And I don't know.
A lot of the towns have their own rules. I know I've been in some towns, like I was out in Goshen. They require a dry well.
Yes.
Other towns, you can put a corrugated pipe right into the ground and just, dump the water in there. And then other towns, right on the grass, whatever you want goes.
Yep. Yeah, everyone's different. And we try to keep it with, we try to keep it simple. If you have, these new houses that have a leaching system, and I'll be honest with you, if sometimes if it has an overflow, we'll still put it in there. The amount of water is so minimal, but dry well is usually the way to go, unfortunately, or a low flow water treatment wastewater disposal system. The problem with those is they're getting very expensive, and nobody wants to do them. So
They used to be like $1,200-$1,500. Now, one of the last quotes I had was like $2,500 to $3,000 to put in.
Yeah, we're seeing like 3,000. There's one company I know that seems to be doing. I think it's Septicology.
Yes.
I know they're doing quite a few of them.
Yeah.
So, but yeah, finding people to do them is not easy anymore. I just wanted to bring to your attention for multiple reasons. First, you'll see they have the grounding straps, which are great. But there's a valve here. I'm not sure where the pressure device is, the pressure switch. So usually you wouldn't have a valve before the pressure tank. So that's a little bit concerning. And then of course you have all this leaking. So other than, recommending that this tank be replaced, I would also recommend water testing if they weren't doing any. And again, we'll talk a little bit more about water testing as well, because I think that could be a big part of all of your businesses.
Hey, Jeremiah, one question on the grounding, and maybe Scott can jump in on this. So you're grounding to a copper pipe. Any electricity has to go to ground, but it's got to go through a plastic pipe.
That's been our fight forever. They're saying the water will carry it. That's inside.
All right.
I don't know. I won't say I agree with it, but we have this fight all of the time. So, yeah, it seems like it's breaking its the continuity.
Plastic can't conduct electricity, can it?
No, but the water inside it can.
All right.
You hope there's grounding rods, but there's probably snow, probably. Jeremiah, I see your sticker on that tank, though. They didn't listen to your advice there to repair that.
Yeah. So for us, I will tell you, well inspections they're not money makers for us. It actually costs us money by the time we do a well inspection. By the time the person books it, we go out there, we do it, we do the report, we send it out, and then the buyer, the mom, the dad, the attorney, the agents, we spend so much time on these things that the only reason we do it is so we could slap that sticker on there, and when something does go bad, at least we will hopefully be the call. I'm sure you guys don't know now with Google, it's whoever comes up first in Google gets the call. They don't know it. These new homeowners don't even go downstairs if they have no water. They just start calling or texting whoever will answer.
Well, I don't know. I don't know how many our members are in Connecticut. There's some out of state, but over the years I used to kind of just the pressure on, it works, got water. So I started using J.H. Barlow, and let me tell you something. These guys have found a lot for my clients. A lot of big issues. Some small stuff always, but for what's it, 185, right? Isn't that where we're at around now?
Yeah.
You go up again this year to come in and do a complete.
No, we'll be going up, unfortunately, with insurance costs and things. So,
but you guys do a yield recovery. I mean, they'll tell me how. You can explain that. I know we got a limited time, but they're definitely have helped my customers out, my clients out on inspection, and help me too. I don't have to put out a fire and say, oh, it's not, put all the disclaimers in. So I do use them as a lot of people use termite guys, and they bring in other guys during the inspection.
Okay.
Yeah. Well, since you brought up well recovery tests, the problem with well recovery tests, and we have it here. So I brought it up in the beginning. If we don't know how deep the well is, it's hard to tell if it's a good well or not. And let me preface it with this. In Connecticut, along with these new regulations of our CUs that we talked about a little earlier before the class, we can no longer condemn a well. So we can't say that this well is only 50 feet deep, and by code it should make 5 gallons a minute. We can't do that anymore. We could just simply recommend some more storage or drilling a new well, but we can't say that the well is bad. And this is a new, again, it's a new regime at Consumer Protection, and they're saying that the only time the code could be enacted is on a brand new well that's being drilled. So if it's an existing well, we cannot condemn it, which is kind of crazy, but we'll go by what they say.
Well, you could say 2 gallon. You could say, oh, it's not really putting out a lot of water. I mean, there's ways around that,
So we just word it where you should consider a new water source, more storage, and things like that. Right. But with that being said, the problem that we face is if we don't know how deep the well is, we don't know how long to run the water for. So if you have a 50-foot well and you run it for an hour and it doesn't stop, you have a great well. I could tell you that. But now if you have a 700-foot well and you only ran it for an hour, you didn't even touch the well. You don't know if you've pumped enough water out or not. So that's why we have to do some extra legwork to figure out what's going on there. So it's not simple where we have guys that, new guys that come to work for us from time to time. Like, oh, my old company ran it for 20 minutes. And if it didn't stop, it was great. So it's amazing how some people do these tests. But we get some information, amperage draw of the pump, wire sizing, pipe sizing. So that way we could determine how deep the well is based off of those things, or at least get an idea, as well as trying to get information from before we even get out to the house from health departments and things like that.
So Jeremiah, if a home inspector's out there doing a flow test,
There you go. I was just going to say that.
that's got to be like a really bad thing then, because they're really it's not really giving you any information.
Well, that's not. I'll disagree with you 100% on that, because
Okay.
the problem we have is when we come in, we stop at whatever's near the. So if the water tank is the only thing that you have, or maybe you have a water softener, we stop there. We don't actually run the water up in the house. So I think it's a great idea to do a flow test to make sure you're getting the flow in the house.
In the house.
Yeah, but I don't think Jeremiah's not talking about that.
He's talking about
Okay.
faucet outside, the hose bib, right?
Filling up a 5-gallon bucket and seeing how fast the 5 gallons fill up.
Yeah, so that's not really helping much unless you know how deep the well is and how much water you need to pump out before.
Okay.
And you're checking the static water level. I mean, if you're pumping, so one of the things we do is we have a static water tester. As long as the well is above the ground, we're checking where the water level is from the top of the ground down to wherever the water is in the well at that point. So if we run it for 45 minutes and the water level started at 10 feet and it only dropped to 20, that's a good well. Now, if we started it and it was at 100 feet and we ran it for an hour and now it's at 500 feet, well, we're going to keep running that because we know that we got to pump a little bit more water to see what's happening.
Okay.
So you don't always get the full picture by just running the water, doing a 5-gallon minute test or anything like that. So
Gotcha.
you could definitely get yourselves in trouble. We've gotten ourselves in trouble with some wells. We've had the unfortunate. It's been unfortunate. We had to replace a well for somebody one time because we did it wrong. So it happens. Everyone makes mistakes, unfortunately.
Yep.
We don't want it to happen often, but it does. This has a lot going on. I'm just going to leave this one as, again, no pressure relief valve, which is a plumbing code. It's got to be there. This one here, I could show you. They have some kind of a chemical injection here. It could be for pH. It could be for chlorine if there's a bacteria issue, but they're injecting something here. And this tank, I would say, other than being from the 70s, is way too small for any house. This is like a 10-gallon tank. So we would always recommend going bigger.
On these tanks, we could tell the age on those well extras, right? Those sometimes it's hard to see the little numbers that are included on there.
Yeah, well extras the hardest. All the other manufacturers have date codes on a sticker usually. So you could definitely tell. Some of the older ones, they're like stamped into the well extra sticker, but the new well extra ones at the base have a gray sticker that say the date. So this one I have because for a couple reasons. One, again, there's no pressure relief valve, and then we had talked about the ground clamp for the sediment filter up top here. So this one has it. I just wanted to show you that. Other than that, this one's pretty simple. This is an old well extra. Again, no pressure relief valve. You could tell just by where the mold level is, where the water comes up to. So you could tell this tank is no good. Normally it would be down below the first weld. So when you see that mold coming up that high, that means that's how high up the water is getting. So we would definitely recommend replacement of this tank.
Is the bladder's failing, right?
Yes. The reason I showed you this one, I don't bash any certain manufacturer, but this tank manufacturer, so if we see them, we're very surprised, but most of these tanks didn't make it past the warranty period. So when we see them from this manufacturer, we usually would make sure we're extra diligent in testing it and making sure the bladder is good. The idea behind this tank in the early 2000s was that the bladder was replaceable inside of it. They didn't try to replace the bladder that was in and have all that iron and manganese. They didn't think that through. So replacing the bladder was never something that anybody did. And they were just terrible tanks, unfortunately. They still make them, by the way, under a different brand. This one here, this would be a little bit troublesome. Should start making you think is why did they put two tanks side by side? It's not usually normal. So usually that would make us think that maybe there wasn't enough water. So they put extra storage in. If this other tank was after this water filter, then that might be a little bit more acceptable. Some plumbers will put pressure tanks after water treatment, thinking it will give you better water pressure. But this is 2 tanks tied together. Should be a red flag and wonder why did they do that? They have a 20-gallon tank to the right and a 44 to the left. They didn't really give themselves very much extra storage, but again, why is it like that? It's just weird. 2 tanks here. So I had said usually if you see 2 tanks, you should be concerned. However, in this situation, they have a very large well pump. And I could tell that by the size here. So when they put in bigger well pumps, they usually do it for irrigation. And what happens is when these well pumps run, most of them need a 2-minute runtime from the time it turns on to the time it turns off. So if you have a small 20-gallon tank, you're going to burn your pump out very quickly. In this case, they put 2 larger tanks in, so that way you get enough runtime for the pump, so it doesn't burn out. So not always when you see large tanks should you be concerned. Again, here we have the control box, but we don't have any of those pump saver devices. And we know at this house there's irrigation and everything else. So I just wanted to show you when there's multiple tanks, it's not always bad. And I had showed you guys that tank back there where a couple slides back where the black mold was up higher. This is usually where you would see it. The waters in these tanks is usually down below this first mold. So if you see the black mold starts getting up here, it tells you the diaphragm is split inside the tank, which is pretty common. Again, you would think that this would be well storage system, or what some people call a harvesting system for low producing wells. In this case, it's a water quality issue. I wish I could zoom in, but on that back wall, you'll see that there's a white board with a filter hanging. And that filter you can see is very orange. This is a clay removal system, actually. And the water moves through it at 1 gallon a minute. So you have to have some storage behind it, so that way you could supply water to the house. So again, it could be deceiving seeing this system, thinking, okay, I have a low producing well. In this case, it was actually a very good well, just very poor water quality. We had talked about a UV light, one of the previous slides. These tanks are open to the atmosphere. So generally, we would recommend installing ultraviolet. After it, again, it's open to the atmosphere. It's in a dark basement. Bacteria could grow. So we have an ultraviolet light there just to be safe. You don't see very many of these systems anymore. Ultrafiltration has come along since, so this system's fairly old. I think it's like 15 years old now. Ultrafiltration is something that's new that takes care of this clay much simpler. But this was our answer 15, 20 years ago. Homeowner spent a lot of money, unfortunately. This one here is actually a storage system. This is for a low producing well on Woodridge Lake in Goshen. And you can see the tight spot they had, but this is an actual storage system. This customer decided not to install any pump protection or ultraviolet protection. They ended up replacing their pump like 3 times after this was installed. But very, very similar system. They actually added piping so they could have a pool water truck fill it every weekend for them before they got to this house. So again, another storage system. This one is just a water treatment system. This is a fairly involved one. There's some iron. There's some injection on the wall here. So there's quite a bit going on with this water. Again, just make people aware that these systems need servicing, usually at least yearly. Some of them are semi-annual. But I could tell you this was definitely an iron removal system based on the iron and stuff we see there. But that's it for that one. Sediment filter. So we get a lot of calls now. Again, you can see this one has a ground clamp, but you could see all this stuff growing on these sediment filters. That's a bacteria. You'll see a lot of the manufacturers now of these sediment filters are giving you white or blue canisters. They're not doing the clear anymore. The reason being is that when the UV lights hit the water and the filter, it allows different bacteria to grow. So they're putting on new canisters now that don't allow the UV rays to get through them. So that's why customers are upset when they replace them now that they're white or blue, but unfortunately, that's how the manufacturers are doing it. You could still find some clear ones, but not very often.
Can't see the filter anymore either. That's probably
Yeah. Again, this is a injection system. So I'm going to just back up a couple slides. So this blue pump that you see mounted on the wall would pump out of something like this. My concern with this is you could see all these open holes, and you could imagine what we find floating in these things. Mice, rats, all kinds of things, spiders. So we would make a recommendation that they should make some sanitary connections there so that way nothing could get through. But again, we see things like this a lot that are just red flag and will contribute to bad water quality as well. This is, again, pretty much just showing you some of the systems that are out there. I know this is another iron removal system. The good thing to note that on this one is the sediment filter is the last thing in line, and you can see it's perfectly white. So it's working. But one of the questions I would show you here is this system's on bypass. So, I would be aware of if they're on bypass or not. Some of them are harder to tell than others. I believe this, so actually in this house, everything's on bypass. I apologize. This was another foreclosure. So everything was on bypass. So I would just, if you do water testing, make that note whether it's the water treatment's in service or in bypass, which may bring up other questions. Where should you, if you're going in to take a water sample, should you do it before the treatment or after the treatment? That's one of the questions we get asked quite often. You guys probably have your opinions on that. I say do both. Test it before and test it after, but we all know that most home buyers aren't going to spend that money. So what I would recommend is do it after to make sure it's working. If you test it before, we know that you're going to get a sample that's going to have a lot of contaminants, whether it's iron, manganese, hardness, pH problems. But if there's a system there, you want to know if it's working. So my recommendation would be, if they don't want to do it before and after, do the after. So we could at least say, hey, that system's working or it's not. This one here was a bad installation, unfortunately. So this tube is actually supposed to be connected to the brine tank inside here. This was I'll be honest with you, a plumbing teacher installed this for a technical school, and he plumbed it in backwards. He ended up causing some water damage to the basement. But just check little things like that when you're out there. Just good people make mistakes, unfortunately. This was a radon system fire. There was some, I think I've showed this one in the past. A company made some modifications to it that didn't meet the manufacturer's specs, and it caught on fire, unfortunately. Air gaps. There's different ways to do it. There's different manufacturers. Whenever it's connected to the source system or septic system or whatever it is, there should always be an air gap. Some people don't like it for whatever reason. Some people do an air gap where they just stick the pipe in. Code says it has to be an air gap, so where there's a physical break. So this is one style of that. I also personally think that for these dry wells that we should have air gaps, but it's not required. I know it's groundwater, but still, it could still pull a siphon and draw on water from that dry well if everything goes wrong, of course. So this is a picture of just an air break. Again, it should be an air gap. There should be a physical break between the tube and this receptacle. So this would be wrong, unfortunately. This is another. I know it's hard to see, but this is a gray fitting here. This is another air gap system. That would meet code. Unfortunately, another air brake. It's not actually gapped. Looks like they have their condensate going in there as well. I'm not sure what this one is. I know we were showing the connection where they did a check valve. So again, no air gap, no air brake. They just did a check valve with a direct connection to, some sewer or septic system somewhere. Another direct connection. And we see this, it's more common than you would think.
I see it all the time.
There's a company, a local company to me here that still taps the mains. And usually there's a check valve. In this case, there's no check valve. So, but either way, it's not right. It's wrong. It should never have been done. There's no grandfathering or anything else. It's just wrong. Again, another one, just a swing check. It's wrong. Never was right. Just again, another bad installation, and we see them all the time, unfortunately. This was a Home Depot special here. Again, back here, this is from a reverse osmosis. So you're putting in a water system here to treat your water to make it great, and here we go, we're sticking it right into the drain. So again, it's just another. I mean, looking at this whole picture, everything looks bad here, but another bad one. We see it every day. This is probably one of the things we see the most. Everyone goes to the drains in a wrong way. Again, another air brake, and this one they didn't even break anymore because they taped the whole top off, so now it's like a solid piece. Because they didn't bring this tail piece up high enough, so the water was coming out of it. This one's good. Well, we think it's good. We don't know where it's going to here, if it's a dry well or if it's septic or source, but it does have an air gap, so that one meets code. Well caps, we'll get into that a little bit. So this, even though this is considered a watertight well cap, it doesn't meet code because it doesn't have a vent. The height should be 6 inches or more out of the ground for any wellhead. There's talks in Connecticut to raise it to 12 inches. If you're aware of this or not, we have 2 different well drilling codes in Connecticut. We have Consumer Protection has a well drilling code that was just updated last year, and then Department of Public Health has a well drilling code, and they're not the same, believe it or not. So the Department of Health says it has to be 12 inches above the ground, but we go by Consumer Protection, which says 6 inches. Department of Public Health code comes into play when it's a school, a restaurant, a daycare, or anything like that. So that's why there's some different codes. It should just be all uniform, to be honest with you. But when you see a cap like this, it wouldn't be a watertight well cap by current code. This is not a watertight well cap either. This was never meant to be a well cap. This is a driller's cap. This is what drillers would usually put on top of the well after they drill it. Unfortunately, that's what was underneath that well cap. So there was a mouse or rat nest, something like that. Again, here there was some, when we took the cover off, there was some varmints living down in there. This is generally what we like to see, a watertight cap. It could be blue, it could be green, it could be plastic, it could be metal. But basically you would see 3 parts, 2 rings and then a rubber gasket. What I should have done is underneath here, there's a screen that allows the well to breathe. If you ask me, it's no longer watertight though, because if water gets above there in any way, it could get into the well. But this is what's current code in Connecticut. A cap has to be at least a 3-piece cap. Just a very nasty well pit. It's not dry and it doesn't have a watertight well cap. So when we see pits like this, it's a big red flag. Again, in Connecticut, we can't make anybody raise their well above the ground. Only on a brand new well could we do that. But FHA, VA, CHFA, any federally backed loan would require them to raise the well casing anyway. So in this case, we would recommend raising the well casing and just getting rid of this unsanitary condition. It looks like at one point the well tank was probably in here as well. I see a pressure switch here. I see some blocks that the tank was probably on. So at least they moved some of the equipment inside. This one has a couple things wrong. In the front, it's 6 inches where the orange tank is. It's 6 inches from the bottom of the ground, but on the backside, it's right at the top of the wellhead. So it's got the wrong well cap, and they have to regrade a little bit there, unfortunately. Another buried wellhead. When we see these wellheads buried like this, usually there's bad water quality. Usually we get coliform bacteria or E. coli because it's hard to keep that water away from the well cap. When the pump turns on, it creates a siphon inside the well, and it pulls the groundwater around the well in. So if you could raise the well out of the ground, you'd get rid of that potential contamination.
What's it cost to raise one of those, roughly, ballpark? I know there's other variables.
So ballpark, I mean, so like we're looking at this picture here. This one would be an easy one actually, because we could actually still get in this hole and work, and raise it out. So this one would be under $1,000. Unfortunately, some of them, they put the well right in the middle, so we can't actually get in there and work, or they put them right against the side of that concrete. I don't know what you want to call it, that concrete pipe, where you can't actually get the couplings on it. So we have to bring in a backhoe to dig them out. That gets to be more expensive. I mean, you get up into the $2,000 range then. Whenever you bring in a backhoe, it gets more expensive pretty quickly, unfortunately. So this one, you could tell water's been getting into this pit. You could actually see where it's coming from. You could see all the sand in the bottom that's washed in. This well cap's good. This is just one of the tests that we do. You can see we're checking the amperage draw as we're testing letting the water run. So this here is our amp meter. We're checking the amperage as we're pumping it, and this is our sonic tester, or one of them, to see where the water level is inside the well as we're doing it, as we're pumping the water. I'm sorry. A couple things wrong here. Again, the wrong well cap, and the well is flush with the ground. So again, you could get contamination. What I'll say about this, I would think that a homeowner probably brought the dirt up in this yard, because these caps usually were 6 to 12 inches above the ground already. Not many people install them below or flush with the ground with that well cap. They would have installed a different kind of well cap. This one looks like a car, a lawnmower or something hit it, but you could see that some mice or something got in here afterwards and built a little nest. Same thing. Someone backed into this one. This was right in the driveway. Again, a sonic tester, just testing the water level. Wellhead not above ground. Bad situation there. You know, this pit full of water. You can see the pressure switch is almost underwater here. This would be a red flag, and you can see right here the wire conduit's going right down. There's nothing blocking any of this groundwater from getting into there. Just a bad situation. Same thing with this one. This was an actual well casing at a home that we did work. Actually, it was a group home that they couldn't figure out why they were getting water quality issues, bacteria especially. When we did some further inspection, this section here, this smiley or frowning face, whatever you want to call it, this was actually buried 4 feet down in the ground. So someone along the line was trying to put some pipes in the well or something, and their fix for all these holes was they put some tin and concrete around it. And 30 years later, it rotted away and the concrete broke, and they got groundwater in the well every time it rained. So this picture has made its way to a lot of places. It's at the state health department. It's been everywhere. This is just another well cap. This is kind of a code thing. I mean, I don't know if many people would catch it. This was just a house I was at. Whenever you have a well, there's a protective radius around it. So it's supposed to be 75 feet from this well. You shouldn't have any sources of contamination. Septic tanks, sewer lines have to be 50 feet. In this case, they put a sump pump right next to it for the house. So that's not a very good a good thing to do. It's a bad source of contamination there. Again, another well in a well pit with a fitting that's open, so anything, mice, spiders, groundwater, anything could get in there and contaminate the well. This one, I think that just says enough. The mice have built a nest around it, so this wellhead's buried right in here. That one's good, and they even have the bollards in the driveway so no one could hit it. And that's it. I'm done with that.
How about swimming pools? 25 feet?
No, they don't have to be.
Okay.
An above ground doesn't have to be. An in ground does. It's got to be.
Oh, an in-ground does.
Yep. Yeah, an in ground has to be farther away.
Can you talk? Oh, I'll go ahead.
Go ahead.
Can you talk a little bit about some of the testing?
Definitely.
I mean, we do a lot of radon water testing, and there's several different ways the lab recommends. When you do a radon test, how do you do it?
So,
Radon.
so the way they're doing radon tests have changed, and some of you guys that are using Aquatech probably haven't changed yet. A lot of the other labs have already switched to the 2 bottles. So I'm sure Aquatech will be coming around with that. But the new protocols use 2 bottles. There's a whole procedure that the NRPP, AARST, whatever. I'm not very familiar with what it is, but they came out with it, and Connecticut adopted it. So Connecticut's following those guidelines. So I can't remember. You have to run a certain amount of water for a certain amount of time, and then do the two vials for water. I'm not 100% up on that, to be quite honest with you. We don't do a whole lot of radon testing, so. I can't answer the radon test. I will tell you though, Scott, you weren't on earlier, but water testing is going to become a big thing here in Connecticut, especially with the new lead and copper rules coming out. Connecticut is huge. I'm sure you've been listening on the news and on TV with some of these lawsuits Connecticut's been filing with the PFOAs and the PFOS and all of that stuff. Currently, there's only 1 lab in Connecticut that tests for it. It's Regional Water Authority lab, and they're not opening up to the public. So, we can't bring them water samples. The state currently is, so they're testing for them. But people are going to be wanting their water tested for these PFOS and PFOAs and the 4,500 parameters that they have to test for. So water testing could become a big part of everyone's business. I know we don't want to do it. I know talking with the labs, they don't have enough people to go out and do it. That might be something good for you guys to get into. But between the PFOS, the PFOAs, the radon, and then the lead and copper rules coming up, there's going to be a lot of testing going on here in Connecticut for sure. So lead testing is going to be big. How we test for lead is going to change. So it's going to be first draw. It's going to be after a flush sample. There's going to be like 5 bottles all together that have to be filled up. So I think the way we do things is definitely going to change coming up pretty quick.
What does it cost? And it's ballpark. I know there's a lot of variables. Could you just kind of maybe mention, what is the cost for softener, neutralizer, UV system? If you could just give us, some of your.
Yeah. So I'm going to give you some ballpark prices because I hate to. So, and I'll give you my area. So I'm going to be really low in Fairfield County. And I'm going to be high in, Torrington. But so what I will tell you is, I'll give you a good, for instance. So water softener, I quoted someone today $2,200. They sent me back, what am I doing wrong? Because the same softener from basically the same manufacturer, just with a different model number, they were getting $3,800 for. So softeners, I would say to install a softener nowadays, you should be spending somewhere around $2,500 on average, depending on the size. We have some city water markets that have very hard water, where there's combined units that will take the chlorine and the hardness out. So more like $2,500 for something like that. Acid neutralizers, I would say somewhere around $1,800 to $2,000. Iron filters around $2,000 to $2,200. Ultraviolet, depending on what you want for, there's different models. So there's different models available with different options. But to install them, I would always recommend, at the very least, you put a sediment filter with it. $1,200 to $1,500 for a system for a UV.
GAC
about $1,600 to install, just like a whole house GAC system.
Like a bubbler or an aerator.
So I have to be honest with you, I don't know anymore.
Everybody's all over the place.
Yeah, so I don't know. I could tell you the last one we installed was $5,200. I was at last weekend. I was at the New England Water Well Association's convention, and they had a guy there selling a system for $1,650. It did not look very good to me, but I have seen it installed recently, and I know that they're installing them for like $3,000. So you could, again, depending on what quality equipment you want, you could get stuff installed really cheap, or you could buy a Radon 08 aerator and spend $7,000. So, depending on what you want to spend your money on, you could be all over the place with radon aeration. But we are
RO.
with radon aeration, and this is something you guys should probably be looking out for. Is a lot of guys are not venting it above the roof; they're just sticking it out the side of the house and 45ing it down. So look out for that. And what I'll tell you is what's happening with that is they're saying it's because they're not using it for radon; they're using it to raise pH. So just be aware of that.
And I know we're about over. Well, what's RO and a UV roughly?
So ultraviolet, like I said, somewhere around $1,200 to $1,500 for an ultraviolet. Our reverse osmosis, again, depending on how many gallons a day you want or what you need. So a point of use RO, you could be looking anywhere from $900 to $1,500, depending on if you want to add a pressure pump to it or if you're just looking for a basic system. If you want a fancy faucet to go with it, there's TDS monitoring faucets that could tell you how high the TDS is. So there's all kinds of bells and whistles to go along with that as well.
Pressure tanks, 800 to 1,000, depending on the size.
So like a 20-gallon tank, you'd probably be looking somewhere around $900 installed with a tank package. So what's happened with the tanks, and you guys I think go up to Amtrol, the steel has gotten so expensive, and then that tank cross package that comes with it in the last year has doubled in price.
Well, Jeremiah, this was a great presentation. We're going to wrap up at 8 o'clock, and we like to keep them in an hour. I want to thank you very much for your time and your information. It was excellent. And if anybody has any additional questions, they can always email it to us, and I'll forward them on to you. But this was really great. Thank you.
Jeremiah, thank you very much.
Jeremiah,
Thank you, guys. I appreciate it.
thank you.